Now we're going to do some basic logarithmic equations. So in this case we have natural log of x minus natural log of 2 equals 0. So we just proceed like with any other equation. So I'm going to do ln x equals, and then I'm going to take that negative ln 2, move it over to the right, becomes positive natural log of 2, and we just compare. We have same base, so x equals 2. We don't need to do anything more here. Next problem, very similar. So ln x minus ln 5 equals 0. So ln x equals ln 5. We compare, and x equals 5. In this problem we have e to the x equals 2. Well, there's no way to rewrite number 2 using e. So what we need to do here is take the log of both sides. And in this case we will take natural log, because natural log has base e. So what happens, natural log of e, it cancels each other, and we're left with x equals ln 2. And just as a little refresher, why is this cancelled? When we write ln, that's same like saying log with base e. So when we rewrite ln of e, that's same like writing log base e of e. So we're asking, how did we get from small e to big E? Which exponent is that? How much is it? So essentially it's 1. So if I ask ln e to the x, that's same like if I ask log of e equals e to the x. So I'm asking you, what exponent did I have to put on this little e here to get e to the x? Well, of course I had to put the red exponent, which is x. Moving on. Next problem, e to the fourth, e to the x equals 4. Take natural log of both sides. And now we have ln and e cancel each other out, so we have x equals natural log of 4. If you're interested how much that is, just put it in the calculator. The next one, ln of x equals negative 1. So in this case, all we need to do is do some rewriting. This is natural log, so the base of natural log is e. So all we need to rewrite is base e, exponent is negative 1, and result is x. So our answer is x equals e to the negative 1, or if you would like to rewrite that as a fraction, you can say x equals 1 over e. This problem, same method. ln of x equals negative 7. Well, our base is e here. So this statement is same like saying e to the exponent of negative 7 equals x. And we're done. This next equation, again rewriting, we have log base 4 of x equals 3. So this here's the 4 is base. Again, what is log? Log is exponent. So 3 is exponent, and what we get is the result. So I simply need to rewrite this as 4 to the third power equals x. And then if you want to get a number, 4 times 4 is 16 times 4 is 64. So 64 equals x, or if you like to rewrite it, x equals 64. Done. The next one. Log base 5 of x equals negative 3. Base is 5, exponent negative 3, result x. So 5 to the power of negative 3 equals x. If we want to get a number, we can rewrite this using rules of exponents and say 1 over 5 to the power of 3 equals x. Well, what's 5 to the power of 3? That's 5 times 5, which is 25, times 5. Let's see, 25 times 5. That's same like 20 times 5, which is 100, and 5 times 5, which is 25, and then you add those two up and you get 125. I just want to show you how I do this in my head very quickly, but this is a slow way of explaining that. So 1 over 125, that's x. Next one. Again, we have base is 10, so 10. Exponent is negative 1, so 10 to the negative first power, and result is x equals x. So 10 to the negative first is same like 1 over 10 equals x. So you can leave it like that, or if you like, you can rewrite that as a decimal. So x is 0.1 or 1/10. Now we have log base 10 of x minus 2 equals 0. Now be very careful here. If you don't see any parentheses, this negative 2 is here by itself. It does not belong to the log. So we'll just rewrite this as log base 10 of x equals positive 2. So we just took this negative 2, moved it over to the right side, made it positive, because we added 2 to both sides, right? And then from here on, my base is 10. My exponent is 2. And my result is x. So 10 to the second power equals x. 10 to the second power is 100. So x equals 100. Moving on. So in this case, we could rewrite again. We could look at number 4. There are a few methods how to do this. But we could look at number 4 and number 64. 64 can be written as 4 to the power of 3. And then we have 4 to the power of 2x minus 7. And we see that our base is same, so we can ignore the base. And we're just going to set our exponents equal to each other and solve. So 2x minus 7 equals 3. So 2x equals 3. Move that negative 7 over here, so 3 plus 7. So 2x equals 10. X equals 10 divided by 2. X equals 5. This was just a little review of solving a linear equation. Let's move next to the next one. So in this case we have again pretty much similar equations like before, just a little bit more calculation. So we have a number 2 and we have 32. Well, I can write my 32 as 2 to the power of, let's see, 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So this here is 1, 2, 3, 4, 5, so 2 to the 5th. So 2 to the 5th on the right, and then 2 to the 3x plus 1 to the left. Let's ignore bases because they are same, and let's solve for x. 3x plus 1 equals 5. So 3x equals 5 minus 1. So then 3x equals 4. So x equals 4, and then take that 3, put it underneath, divide. So 4/3, x equals 4/3. On to the next one. Well, for the next one, we'll have to do some more rules, so let's actually break video right here, and let's move on to the next video.